What is y when x is 6.5? So 6.5 is here. If we follow that up and then follow that over, we get our answer 16. Based on the line of best fit, if the width is 19 millimeters, what's the predicted length? So the width at 19, so 16, 17, 18, maybe about here. If we follow that up, it's going to be above 50. Let's extend that line a little bit. Doesn't seem to be quite at 55. C is our answer. I suppose you could put 19 into this equation if you wanted to find a more precise answer, but either way the answer is C. C is a positive correlation, and while A goes down, it's not a strong correlation. D is strong because all of the points on the scatter plot are close to a line of best fit, or closer than A. How many people have an actual height that differs by more than 3 from the predicted height? So right here is a distance of more than 3, more than 3, more than 3, and more than 3. So the answer is 4. They want to know what is the most appropriate linear model. So the slope is negative. Any of the ones with a positive slope can be ruled out. And our intercept is at a positive 7. So that rules out B. Here's our answer. For the player with 450 at-bats, their actual is how many fewer than the prediction. So here's 450. If I follow that up, here is the actual, and here is the line of best fit. That's pretty close, even with a scale of 25. The smallest one is going to be the answer here. An astronomer has discovered a new planetoid about 1.2 AU from the Sun. So if we follow 1.2 up to the line of best fits, we are here, above 4.5, so these are wrong. And we're definitely not up here, so I'm going to go with C. Based on the line of best fit, what is the predicted height from someone with a first metacarpal bone that has a length of 4.45 centimeters? So 4.1, 2, 3, 4.5. We follow that up. This is our prediction. We are at around 169 or 170. Turns out we have to be very precise, so if we follow 170 over, there's our answer. We have actual data and a line of best fit. They want to know the closest to the difference between actual and prediction in 2003. So if we follow up with 2003, here is the predicted, here is the actual. Our scale is counting by 500. We can see that we go a full unit and then maybe another half. So 1.5 times 500, and that's where we get our answer, 750. How many of the trees in the sample is the number of growth rings greater than the number predicted? So just has to be greater than the prediction. Here's 1, 2, 3, 4, 5, and 6. The answer is C. If we were to make a line of best fit, it might look something like this. And they want to know which one is farthest away from that. So over here, and they ask for the width, which is 7. Which of the following linear equations is the most appropriate model for the data? So if I do something like this for my line of best fit, I can see that my slope is going to be negative. I can cross out all the positive slopes. And I know that my intercept is going to be positive. So A is the right answer.